In this video, I'm going to discuss sections 8.2 and also 8.3, just because they are very similar. So in 8.1, what we did is we talked about the distribution of sample means, or the sample proportions. And we said, okay, well, what we want to do is we want to be able to get a sample and then generalize our information out to our population. And we calculated the sample mean. We got used to the different notations. So we had, or the different variables. So we had things like p, p hat, sigma, mu, capital N, lowercase n, etc. What we're going to do here is we're going to expand on that a little bit. So even though we're able to use a best estimate value, so let me get my annotation going here. So before we were able to get a best estimate value. So for example, we would use the sample mean as the best estimate. For the population mean, we need to have a way to be able to tell how good that estimate is. So what we do here is we create what is called a confidence interval. In this text and in this class, we're mostly just going to be working with 95% confidence intervals, and I'll explain that a little bit more as we go along. But this confidence interval is going to be the range of values that's likely to contain the true population mean. Whenever we're writing this, we're going to see we're estimating our true population mean, and we're going to put it between two different values. So we're going to create an interval. So we're going to have mu between whatever our best estimate or our sample mean is, minus some margin of error. And then we're going to take that same best estimate and add the margin of error. Somewhere in there, we're going to say that 25% of the data is going to be in that range. So if we take samples of the same size, or all possible confidence intervals of the same sample size, 95% of those would have our true population mean. Or we could also say with 95% confidence, the true population mean is in that range. And once we go on to the questions, we do have one where we're doing the interpretation. So I'll explain that a little bit more. We can also denote this just in interval notation. So instead of having it in our inequality notation, we can write it in the interval x bar minus e to x bar plus e. Let's talk a little bit more about what e is. We've seen so far we have a margin of error. So we're saying, okay, before we might have seen it in a problem saying within 5 degrees. So if we're talking maybe about a fever, we would say fever lies plus or minus 5 degrees away from some mean body temperature. We're doing the same thing here, except now we have to calculate that margin of error ourselves. So it's not going to be directly given to us most of the time. So the margin of error, we're taking 1.96 times little s, and remember that this is our sample standard deviation. And we're going to divide that quantity by the square root of n. We will work a little bit more with that, but let me go ahead and scroll down just to introduce another thing we're going to be doing in this section as well. I'll go ahead and clear that. One other thing that we're going to do in this section is we're going to be given a margin of error. And so we're kind of going the opposite direction with it. Before we have to calculate it and construct an interval. Now we're saying, okay, well, if we have some specific margin of error, and we have some some best estimate value for our standard deviation. So this is and. Let's say that we want to figure out the number in this sample size. So this is a real life application of this concept. A lot of times in the medical field or in any experimental field, somebody will say, okay, I want to construct an experiment. And what I want to do is I want, let's go back to a body temperature example here, for example, body temp. They said, I want to know how many people do I have to have in my study if I want most of my people to be within 5 degrees of my mean, right? So here we have to say, well, how many people do we need in our study? And to calculate that, again, you're going to see this 1.96 value. We're going to multiply it by sigma and divide it by our margin of error and square that entire value. Once we get a value here, we have to round up. So if I'm saying that I need 13.4 people in my study, I can't just say I need 13 because I'm not going to have enough. I'm not going to meet that minimum sample size. So I always have to round up that number, even if it's not following our standard rounding rules. So if I had the little n value of 13.4, I actually need 14 people. Let's take a second and move on to some of the questions. So I'm going to erase this and scroll down. Questions 1 through 3 were answered and discussed in the last video. So I'm going to pick up with number 4 here. We're going to work out 4, 5, 6, and 7. I'm going to go with back to black here for my font. Number 4 says one study involved a sample of people's body temperatures, and it resulted in this 95% confidence interval for the mean. So we're saying we've got a confidence interval for a population mean, and we know that the confidence interval is in between these two ranges. And we want to interpret this confidence interval. Actually, I will go back to blue. It's a little bit easier to read. So if we are looking to interpret a confidence interval, and we always need to include this. So anytime there is a confidence interval, you have to include an interpretation. Every time. So even if the problem tells you to do it or not, if you have a confidence interval, you must interpret. So if we're looking to interpret this one, we know that we have a 95% confidence interval. So we can say with 95% confidence, we can say that the true, and then it's whatever population value we're talking about here. So we're talking about our body temperature, so people's body temperature, and we're talking about the mean. So we're going to say that the true mean body temperature of whatever our population is, so of people, is between the values that we have. So between 98.1 degrees Fahrenheit and 98.3 degrees Fahrenheit. Let me change the color here just to highlight some of the items that we have to have in that interpretation. We have to have the level of confidence. We have to say the true, whether it's mean or proportion, which we'll see in the next section, whatever it is we're measuring, and then our population. Always also make sure that we are including the values in that confidence interval. I know that it might be a little bit hard to read here. Just keep in mind that I do have this problem worked out on the key that's posted online. Let's move on to the next one. So number 5 says, a sample of 100 babies born at some hospital has a mean weight. So I'm going to go ahead and just circle this as we go along. Sample of 100 babies has a mean weight of 3,072 grams and a standard deviation of 748 grams. Use a single value to estimate the mean weight of a newborn baby. Also, find the 95% confidence interval. So we have 2 things we need to do here. I'll use a different color for both just to help visualize what it is that we're talking about. So it says use a single value to estimate the mean weight of a newborn baby. What it's asking for here is our best estimate. And remember that our best estimate is the mean that we have from our sample. So here, our best estimate is that 3,072 grams. That's best estimate is the 3,072. It says also find the 95% confidence interval. I'll draw a line here and just to separate it. Remember to find our interval. We're saying that mu, because we're talking about mean, mu is between x bar minus e and x bar plus e. We know our x bar value because we were given that value directly. So I'm going to take that 3,072 minus e, and then that 3,072 plus e. So now we're left having to calculate a value for e so that we can actually figure out the bounds of our confidence interval. Remember that e, or the margin of error, is 1.96 times the standard deviation over the square root of n. We have 1.96 times our sample standard deviation, which is at 748, over the square root of the number in our sample, and here we have 100 in our sample. Once we calculate our margin of error, we should have a value of about 146.6. You'll see sometimes they say to keep the margin of error to be to the same number of decimal places as the mean. I do not stress that, so your homework might, but just know that on a test, it doesn't matter to me how we round. So I'm okay with keeping this at 146.6. If you feel more comfortable having it at 147, like your homework asks, that's fine as well. So now I'm going to take the 372, or the 3,072, and I'm going to add and subtract that value to get my interval. So I should have an interval of 2,925.4 and 3,218.6. This is our confidence interval. Notice that the question does not ask you to interpret that interval, but you must include it every single time. So I'm going to go ahead and clear just this right side over here where we calculated the margin of error, just so I can include our interpretation. So interpreting this confidence interval, we can say with 95% confidence, we can say that the true mean is what we're talking about here. We have the true mean, 95% confidence. So the true mean weight of all babies born at that hospital and I'm just putting at that hospital instead of writing it out, is between 2,925.4 grams and 3,218.6 grams. I'm going to go ahead and clear that and move on to number 6. Number 6 says a government survey is to be conducted to estimate the mean price of houses in a large metropolitan area. It is designed to have a margin of error of this value, so of $10,000. Pilot study suggests that the population standard deviation is $65,500. Calculate the minimum sample size needed to estimate the population mean with 95% confidence. So here we're looking for our minimum sample size needed. We need to use that formula, n is equal to, and remember it's n is equal to 1.96 times sigma over the margin of error squared, that whole value squared. So now we can go ahead and substitute in the values that we know. So we know that the 1.96 is given. Our value of sigma, so the population standard deviation, is 65,500. And our margin of error that we want is only within $10,000. And then we're going to square that whole quantity. I recommend calculating what's on the inside of the parentheses first and then squaring that value. So I had about 12.838 squared, which gave us about 164.814. Again, keep in mind that we always do want to round up here. So in order to stay within the margin of error of $10,000 and to suggest that our population standard deviation is 65,500. So we're saying, okay, if we want a range of about 55,500 up to 75,500, we need to sample 165 houses. Let's move on to number 7. Number given says, find the margin of error and sample mean corresponding to this 95% confidence interval. And we're given mu is between 98.0 and 98.6. Margin of error and sample mean. Remember what we're doing in a confidence interval is we're saying x bar minus some margin of error and x bar plus some margin of error. We know then that this value of mu is directly between that range, or on the inside of that range, right in the middle. So if I look to find the middle value between 98.0 and 98.6, I can add those and then divide by 2. It's going to tell me the value that's directly in the middle. So I should have a value of 98.3. And now I'm looking for our margin of error. So I know that this 98.6 minus that 98.3 is going to give us a difference of 0.3. So notice that this is telling us our mu. Mu is directly in between those two other values. So again, just to give a better idea of what I'm doing here, this is x bar minus e, x bar plus e. This entire value here is that 98.0, and then we have this 98.3. This entire value here is this 98.6, and then we have mu is 98.3. So I can find my margin of error between the two. So 98.6 minus 98.3 is 0.3, and 98.3 minus 98 is 0.3. So now I can see that x bar is 98.3, and our margin of error is our 0.3. I actually, just for time purposes, am going to end this video here and then have 8.3 on its own. I was hoping to add it in together, but I think it might just be a little bit too long of a video. So I'll end this one here and then pick up this next video talking about the formulas needed in 8.3.